Okay, so yeah, thank you for the introduction, Gavin. My name is Mark Congdon. I'm at Hydromax USA. A couple quick things about me for those. I looked at the participants list, recognized several names, so thanks for those that joined. I currently live in the great state of Idaho. Moved here recently. My wife and I met here many years ago and made our way back, so we're grateful to be here. I'm an undergrad from Arizona State University and master's degree from CU Boulder. So Pac-12 conference all the way. Let me give you just 30 seconds about the background of Hydromax if you haven't heard of us before. Cool to have back-to-back utility presentations. I'm going to focus slightly differently than the guys just did in Cave Creek with Bad Elf. But Hydromax, we are a professional services company. We specialize in data collection to support the assessment of utility infrastructure. We've been around for almost 20 years. Officially incorporated in 2003, but really around longer than that. We're kind of focused in three specific areas: gas, which I'm going to talk about today, but we also have divisions in water and wastewater. So just kind of give you a high level of what Hydromax is about. So today, what I want to do is I want to look at natural gas utility compliance requirements. So there are very specific requirements. Anyone that owns and operates natural gas infrastructure has to do a variety of things. The example I'm going to use today is leak survey. So Gavin was mentioning that we have an army of people on an RTN every day out working, and that's true. We have quite a few people that are out there. So I'm going to use that as an example of how we use GNSS solutions in enforcing and managing natural gas compliance. And really, you know, what this all leads to is, can we create some actionable business intelligence from the data that we collect? We're not collecting all this data just for the heck of it. I'm going to talk a little bit towards the end about what we do with all of this data that we collect. But just to kind of set the tone here, natural gas, different from water and wastewater, which is annoying when you have a leak or a problem. Not necessarily with gas. Gas is pretty significant. There was a natural gas leak that unfortunately they happen from time to time. It's even made some legislatures concerned. This was a natural gas leak back in 2016. It was triggered in the early morning. Luckily, there's no fatalities, but as you can see, there was quite a bit of damage, millions of dollars worth of damage, and it was caused by what has been, the term that's been coined is outside force damage. So if you were to look at, throughout an inspection, if you looked at a gas meter, it might be fine, it meets all the acceptable standards, but some of the protections, some of the areas around the meter might make it susceptible to some kind of outside force damage. So for example, if you ever went to, say, a business and you see a gas meter outside and those concrete and steel poles are outside of it, well, every now and then you'll see one where a large vehicle bumped into that concrete pole and maybe knocked it over or something. And it hasn't been replaced. Well, that makes that meter then susceptible to some type of outside force damage, which was the case here. It was not because of one of those concrete pylons. It was something else. There was a homeless encampment around this gas infrastructure that caused a problem. But there, again, no fatalities, not even really any injuries, but a lot of property damage. Pretty difficult images to look at. You see entire sheets of plywood blown up in the air that ostensibly were nailed down before that happened. Here's a picture that was in the newspaper of some of our team following a police car into the area. Some of the equipment that they're wearing we'll talk about. Some of it you'll recognize from right away, but others we'll kind of talk about, and we'll talk about how that works. And an emergency is a little bit different than a typical leak survey, but we'll kind of get into all of that. So what are the compliance requirements? Well, there's a couple of agencies to be aware of. One is called PHMSA, PHMSA. PHMSA is the Pipeline and Hazardous Materials Safety Administration, and they write, the CFR is the Code of Federal Regulations. So this regulation 49 CFR talks about requirements that any natural gas utility has to meet. So whether you're a large investor-owned utility or even a private utility, or you're a small municipal or even a co-op with 15 gas meters, the requirements you have to meet for inspection. You have to proactively go out and look for leaks. It's not enough to wait for a business owner, a resident, or a constituent to call you and say, and have what's known as an odor call. There's not enough. The example here for the state of Washington, there's Washington state regulations that require that you go out and proactively investigate and look at your infrastructure to make sure that you're not causing any issues. And these regulations have teeth in them. You can be fined. You can be fined a lot, millions and millions of dollars. Besides the damage that has to be repaired, you can just be straight up fined if you're not meeting the requirements. They're very specific, and you need to know what those standards are. Every gas utility is aware of those standards. For a large utility, there's entire departments dedicated to making sure that those standards are met. So what is that standard? Well, it's broken down into residential areas, business areas, high occupancy structures is another one. When we look at the document of record, what is a document of record? Well, for years and years, it's been a paper plat map. And I'm going to show you an example of that here in just a minute. We're going to talk a lot about paper. And so because you have these requirements that the utility have to meet, you have to make sure that when asked, you can actually provide those documents. And so there are literally boxes and boxes of paper that have to be rummaged through when that happens. So you have the obligation to prove that you did the inspection on a certain interval. So residences need to be looked at once every 3 years. Businesses are once a year. If you're a high occupancy structure, which is generally defined as at any point given a day, are there 25 or more people in that area? And if the answer is yes, you can be designated as an HOS or a high occupancy structure. And if you do, then you need to have leak survey done every 6 months. In the city of Seattle, when the tunnel boring machine was going underneath Seattle to dig the tunnel that replaced the Alaskan White Viaduct, it was not every 3 years or every year, every 6 months. It was every single day. Prior to, all during, and following that tunnel boring machine working, we did leak survey over the tunnel boring area every single day. Christmas, your birthday, snowing, rain, Easter, it didn't matter. Every single day, we had to do those investigations. And all of that leads up to an audit. Sometimes it's called a compliance audit or a regulatory audit. And unlike the IRS, where you hope you don't get audited and you could go your whole life and never be audited, not the case for the regulatory agency. In the state of Washington, it's called the UTC, Utility Transportation Commission. It's different from state to state. In Colorado, it's the Public Utility Commission. The name varies, but they all do the same thing. They regulate those utilities. And the audits are scheduled. It's not if, it's just when. And when the auditor comes in, they're going to ask some very specific questions that you have to be able to answer. So during those audits, there's lots of areas that you have to look at. In general, what you need to do is you need to have someone carrying a methane detection device, something that will sense for the presence of natural gas, walk over the top of where your distribution mains and distribution service lines are. In other words, the main that goes, so let's talk about residences. So if you live in a neighborhood and let's say you enter your neighborhood and it leads up to a cul-de-sac, somewhere on in the street there will be a distribution main that runs, and then off of that main will be a service line going up to each home. And so you've got to, every 3 years, you've got to walk above those to make sure that they're not leaking. You've got to go to the actual meter, take a look at it, and make sure it's in functioning order, it's not leaking. You have to make sure there's no atmospheric corrosion or other kinds of issues. And so there's lots of obstacles that happen. In this image to the right here, you can see the technician with all his equipment going up and over a fence with a ladder. Cannot get in, which is actually known as a CGI. In some cases, it's a CGA for can't gain access, but a CGI or a CGA means I can't get to the meter. So what might prevent you from getting to a meter? Well, it could be a lock gate, it could be a fence, it could be someone stacked plywood over it because they're doing a remodel. It could be because they have a Doberman or some other dog in the backyard and you can't get in there. All kinds of reasons why you can't complete that house. You have to look at the high occupancy areas and high occupancy structures. You have to look at that atmospheric corrosion to see is there any corrosion on that meter. In a really dry area, it's going to be small. If you're in a high salt content environment, like on a coastal town, it could be really different. You need to look at abnormal operating conditions, which is kind of a wide variety of things, but it could be simply that someone chained their motorcycle to their gas meter so their motorcycle wouldn't get stolen, or they tied their dog to it, or their clothesline is attached to it. All of those are things you're not allowed to do with your gas meter, but they happen all the time. Sometimes the grade changes. Someone regrades their yard, and all of a sudden their meter, which was well above ground, suddenly is partially below grade, and so we call that a buried meter. That's an issue. Pipeline markers are those little narrow yellow stakes that identify that there's a gas line underneath, and there's rules about where and how often those pipeline markers need to be. Water crossings is when a gas line goes under a body of water, a river or a lake or something. You still have to inspect those even though they're underwater. And then you have to be able to produce calibration records that shows that the equipment that you're using has been calibrated and it was within the calibration period when you used it. And each technician has to be operationally qualified, and we call it the OQ process. And if you're not OQ'd, then you're not allowed to do that investigation. And if you did do an investigation without being operationally qualified, then that survey is invalidated. So we have all this gas infrastructure, we have meters, we have pipelines, we have mains, we have service lines, we have valves, we have all kinds of things we have to look at. How can I provide evidence that an inspection was completed at the time, date, location required? Because I've got a specific date by which it must be done. So for decades, this image here on the right was the system of record, a piece of paper. Plat maps are typically large, maybe as big as 2 feet by 3 feet. And they're folded in a specific way, and you see, you print out what the gas infrastructure looks like. So this is a plat map, by the way, in case you haven't heard that term. Plat just means that it shows the property boundaries for someone's property. And so you can see here on the left in this image, this is a scan of a paper plat map. You can see the streets, you can see all the different properties, and then you can see the house numbers, and then overlaid on top of that is printed on the paper plat map is the gas distribution mains and distribution services. So these maps are literally passed back and forth to the field. They're generated by the utility. They're given to the service provider, in this case Hydromax. We then distribute them out to the world to get the inspection done. And then as the individual walks up this particular street, as they finish that and they walk up to the house, they literally pull out a Sharpie highlighter and they highlight it, and that is the indication that they're done. And this then becomes the document of record that is then kept. So there's obviously some shortcomings in this method, even though it's been used for a very, very, very long time. Not the least of which is, you know, let's say the technician, his name is Steve, and Steve is out there and he does this light blue section in this lower left or lower right. That's great. But I don't know how, if I gave Steve that map on Monday, I don't know on Thursday how much of that map is left. And each map is different. There could be 500 gas services on a map, or there could be 2, depending on how the boundaries are set up. So visibility into partial completion is really a problem. And all of that work becomes difficult to manage and update. So as we look at this, I'm going to kind of quickly go through a couple of slides to talk about some of the difficulties of the traditional league survey, not the least of which is printing all of that paper. You have to print mounds and mounds and mounds of paper. $100,000 a year is, you know, for a large utility is entry level in those maps. And anytime you have something on paper, it can become outdated, it can be lost, it can get rained on, it can get torn. All kinds of things can happen, and sometimes they have to be reprinted. And once you complete that work, you got to save it. You got to put that paper somewhere. If you've been inside some of these utilities or municipal buildings, you see rows and rows of these storage facilities. And if you run out of space, you got to take it to a third-party storage facility. All of that takes time and money. And by the way, when the audit comes, you got to go get that paper so you can show it to the auditor when he or she asks. This is the other part of that. So your employees, your technicians have been operationally qualified or OQ'd. So how do we know that they actually walked where they said they walked? They highlighted a piece of paper that said, you know, I walked down Northeast 67th Street, but did they actually do it? A lot of utilities will have a capture the flag system where they literally will hide a flag at a random address. And if you really went to that address, then you'll see the flag. But if you didn't go to the address, then you won't see the flag, and your investigation can be invalidated. All kinds of crazy things like that. We talked a little bit about this concept of cannot get in or cannot gain access management. This is a zoom in of that map, and you can see there on kind of that middle right-hand side of the page, you can see that blue highlight. kind of doesn't completely go up to that square. The square represents the meter. The line represents the service line, the gas service line. And they didn't complete it, and they didn't complete it, and then they took out a pen and it looks like they wrote C9. That's actually a G. So CG, which means cannot gain access, or can't get in. And that's it. And then they turn that map in, and then someone's got to go back later and figure out, hey, where did we not get that? That leak survey still has to be done, but I can't see it. So then the handoff to have that followed up on later is pretty painful off of a paper map. Falsification of records. I hate to talk about that, but I mentioned it briefly a moment ago. You never want to accuse a technician of that, but the only record that this technician did this address at, house number 1641 or this house number 16935 is we have some blue ink on a piece of paper that says they did it. Hopefully they really did it, and hopefully they highlighted it when they were standing in front of that house. But is it possible that they could highlight it sitting in an IHOP? Yeah, actually you could. There's no other evidence aside from maybe this capture the flag process to prove that you really were there. And so it's kind of a scary thing that keeps utility owners up at night. Map revision. This is another one. So we have a map that says, hey, the meter is on the left side of the house and it's about halfway back on the house. What if it's not? What if it's on the right side of the house? What if the mapping is just wrong? Well, then the technician has to stop, pull out an 8.5 by 11 piece of paper and fill something out and say, hey, it's not on the left front of the house, it's on the right front of the house, or it's the right rear of the house, whatever that is. And then that piece of paper has to be turned in, and somebody's got to enter that later and then update the mapping. It's a painful process. Now, this is a GNSS webinar conference, and so I know you guys are getting ahead of me and you've all already thought about ways to make this better. Don't get ahead of me. We'll get there, I promise. Accountability for a true investigation. This is the other thing that keeps utility providers up at night. If a technician using their equipment walks past the leak, they have a device. So the gal in of the two people there, there's the guy on the right and the gal on the left. You can see she's holding in her right hand a little blue device, and she's got a cane in her left hand with a cone on the bottom of it. That's the methane detection device. I've got a better picture over here in a minute, but that device will alarm to say, hey, I'm sniffing. It's literally got a vacuum pump in it that passes air through a sensor. And if it senses the presence of methane or natural gas, it alarms and tells you not just that some's there, but how much. Well, if that technician is listening to something on Spotify, or which they're not supposed to do, but if they do, what if they walk past a leak? What happens? And so we'll talk a little bit more about that a little bit as well. And obviously, there's no spatial correlation when you record those leaks if they're all on paper. Okay, so how can we improve a traditional leak survey? Well, again, we've got this huge stack of paper maps. We've got all of these colored markers in stacks everywhere. We've got people driving around shuttling pieces of paper back and forth in and out of the territory. And even after all that work, even though this is the document of record that says you really did it, did you really do it? I hope so. Was public safety improved by this process? I hope so. But all of this manually collected data, how do we consume all that? Well, so we're now going to shift and talk a little bit more, as Gavin put it, where the rubber meets the road, on how we employ some GNSS solutions to help this gas utility. So first of all, again, the people on this call are probably really used to this, but let's talk about how this is used for utilities. So is GPS or GNSS solution, are they widely used on these outdoor fixed assets by gas utilities? And the answer, unfortunately, is not really. Very few are really embracing this technology. So I told you there's lots of rules from PHMSA and state regulatory agencies. Is GPS collected data required for leak survey? It's not. You do not have to do it that way. You do have to prove you did it, but at the moment, that paper record is all you have to have. Will it be important in the future? Well, that's a question, and I would say likely. I think the writing's on the wall. PHMSA released an update recently to their CFR 192 about pipeline safety, and there's now more language about location. Now, they're still not required that location be completed through the use of any GPS or GNSS solution, not to mention high accuracy, but we're moving more into this tracking and traceability information that includes location. In the state of Washington, just this year, back in February, the state legislation passed a new law that went into effect in June of this year that in summary says to encourage a safer and more efficient natural gas transmission distribution system, they in the section 3.3.a, the location of each leak is becoming more important. Now again, they did mention GPS. I actually read this House bill, believe it or not, and they talk about GPS being an option, but because of the expense and all that kind of stuff, it's not yet required, but the writing is definitely on the wall. Okay, so let's talk about accuracy for a minute. Let's assume for a moment that we can that we're going to use a GNSS solution. What accuracy is good enough? Is cell phone accuracy good enough? Well, so I guess I always tell people that really depends on what you're trying to do. But just for fun, we laid some accuracy in front of this house. And so if you have really poor accuracy, let's say you have cell phone accuracy or worse, you might know that you're somewhere in the front yard of that house. You don't know if you're really left or right. You're just somewhere in that front yard. And then as you get down to, you know, 1 meter or sub-meter, okay, now I know I'm left or right. I've got a little better idea. At Hydromax, we really adopt a sub-foot standard. We want all of our GPS to be sub-foot. As Gavin said, we are, I think we're the #1, at least in volume of consumers, of licenses for RTN networks in our different territories. We never use autonomous GPS. We always have something to make sure we can get much better accuracy, because we not only want to know, hey, are we close? We want to know right where we are. I'll show you in a moment. We take point features at the house where we do the meter inspection, and you know, we want to make sure that we're in the right place. Okay, so I'm going to go. I'm actually running out of time, believe it or not, so I want to kind of keep going. But we want to do more than just add GPS. We want to have more things as well. We want to make sure that we have data transfer. We want to get rid of these physical plat maps for all the reasons I stated, but not to mention, you know, during the height of the COVID problem, we were actually quarantining the actual pieces of paper, you know, as we were getting guidance from the CDC and other places about, you know, where this virus could live. As people physically are getting together and passing off pieces of paper, you create this opportunity for contact. And so in a digital system, all of that goes away. So anyway, let's keep going. So for field data collection, what we have standardized on is we use a Trimble R2 GPS receiver. We have many of them. We use smartphones for data collection. We can use Android or Apple. Most of our stuff are Samsung Android devices. We are a business partner with Esri, so we use a lot of Esri software. This one is running Survey 123. We use Fleetmatics to track our vehicles, so at any given time we know where all of our vehicles are. For the actual sensors, we have a variety that we use. The Heath DPIR is the one we probably have the most of. That's the blue sensor that I was kind of showing in the other picture. It has a vacuum pump inside that pulls ambient air in and tests it. The Sensit PMD is the same. The Pergam down on the bottom is a laser, and as the laser passes through molecules of natural gas, then it knows what's there. There's some vehicle mounted, there's drone mounted, there's all kinds of ways that we can do that. So that's some of the equipment that we use. But let me talk a little bit about what we do with the data. So now we're moving into a digital solution, right? And so now if you look at, we've got a similar picture of that same team that was going over the fence there. But in the lower right here, now instead of having a paper plat map where someone scribbled a C and a G that look more like a 9 than a G, now we have an icon on a map, and that icon now becomes queryable. The light blue border on the outside indicates what kind of cannot get in, whether it's a gate or a dog or an owner with a gun happens, all kinds of things. And so now we're starting to build some of that intelligence. So let me go through these really quick so I can get to the end. When we do a report, we can use high resolution imagery to show where the work was done. This one's a cross-bore project, not a leaf survey project. But we can, instead of having that 8.5 by 11 piece of paper that we use in arts and crafts project to draw a picture, now we have high resolution aerial imagery. We have a lot of data in there. And now I have dashboards, right? Now I can start looking, this particular tool is called Tableau. We use Tableau to look at progress of how much work is done. And if I have just part of a map, I can still see that data. I can do actual mapping. Again, this is a cross-border project where sewer lines are being scoped to see if there's any intersection with gas utilities. But again, I can see addresses were cleared. I have all this dashboard information, which is now becoming more and more popular. This is an audit for an employee. If there was some type of tragic event happened and the UTC came back, or whoever the regulatory agency was, they came back and said, hey, you said that this employee did the inspection. I want to see the training records. Well, now they're all here. You don't have to try to find some sign-in sheet from a meeting you had 6 months ago. All the data is there. And so I want to talk now a little bit about how we collect what's called breadcrumbs. Similar to the previous, I listened to the last part of the previous presentation. Breadcrumbs, we take a point every 1 second as the employees walk, and then we have a separate point feature for every meter investigation that we do. And what that does is now we can do digital highlighting, so we don't need that Sharpie highlighter anymore. We can actually use the breadcrumbs from the person, the technician who's just walking. We can write rules such that if you see kind of on the left top of this image, you can see that green service line up to that house. Those breadcrumb dots are within a tolerance that are prescribed by the utility, and if they are, then no more pulling out a paper plat map or anything to highlight it. All those dots line up. It's not a line feature, it's a section of point features, but the collection of them make up the highlighting, and so you can see that they're done. And the other one here where I talked earlier about what happens if a technician walks past a leak. Well, on paper, if the technician is not doing his or her job and they walk over a leak, that data is just kind of gone forever, which is not the case here. Every breadcrumb that you drop, we have a connection to the methane device, and we know the parts per million reading for every single breadcrumb. We collect millions and millions of breadcrumbs every week. And each one has the ppm rating, so we know exactly what work was done. And so if there's not a leak investigation associated with a high ppm reading, then it's bad that the technician missed it, but at least it's not gone forever. We can go back and check it out. Okay, map revisions, the same thing. We can communicate electronically changes that are required for the map. Okay, so this is kind of the last section here, data available for business intelligence use. So this is that paper plat map that we saw before, and we want to replace it with this. We now have a live map. Now this is a static image, but in general, if you were not in this presentation, but just looking at a computer, this is a live map with all the data that's there. So you can see all of these initials, most of them are FW for Frank Williams. He's the technician that did all the leak investigation. Because it's GIS, I now have a layer list over here on the right, and I can turn on and off whatever I want to look at. So if I'm investigating this neighborhood for whatever reason, this is a residential neighborhood, I can turn on all the breadcrumbs if I want to and say, I can see exactly where that technician walked. And I can see if they missed anything. If they missed an entire house, I can see it. If they couldn't get in, I could see it because the breadcrumbs don't go. So I can turn breadcrumbs on and off. So let's just pick one of these at random. So if I pick this investigation, again, this is a point feature when the technician's standing in front of the meter, and I can click on that, and while the technician was there, it took a picture of the meter, and he got some data about that meter. And so they'll take a picture of the entire meter set assembly, and then they'll take a close-up of the serial number. So I don't have to worry about whether I fat figured in the serial number of the meter. I can actually have a picture of it. And then I have a picture of the utility asks, take a picture of the worst corrosion that you can see on that meter. We take a picture of that. So now that could be looked at by the corrosion prevention department, separate from leak survey. And then if I go over here and if I just choose a breadcrumb, I can click on that and I can see information about that. I can see the time and the date that it happened. I can see a lot long where it was, and I can see that the parts per million reading. Was it a 0 or was it some other number? So all of this now becomes data rich, for the utility. Instead of just this two-dimensional piece of paper, now I have all this information at my fingertips to use however and whenever I need it. So in the interest of time, I won't go through all this, but these audits that again are not optional, they're going to happen. You have all this information available to you. The data is collected. You don't have to rummage through crazy filing cabinets to try to find everything. All of that is there and is ready to go. So with that, I'm at the end, and I'm gonna go out of presentation mode so I can actually see the camera.
Yeah, thanks, Mark. That was a great overview. This was the rubber meets the road type, this in the example in the last presentation. So question about, I see your crews around town, and
Yeah.
I see where they've got the receiver pole in the backpack.
Yep.
Now, so, where you're standing, every shot's going to be within a meter, but, right under that pole in the backpack, it's decimeter, probably even tighter. Do they ever like turn around and put the pole over the meter, over the water or gas meter to try to get a better shot, or is that not really that necessary for this application?
Yeah, so so I wish they would. So they have to be looking at the meter to answer the data dictionary type questions that are in the survey form. So they need to be able to see that. But yes, we do ask them as part of their training to get as close to it as they can, and to make sure they can get the best position that they can. We realize that there's some error introduced by it being on the body there. And not everyone completely knows exactly how the whole system works. Every now and then I'll see a slouchy backpack where the antenna is kind of wonky, and so we've got to correct that. But yeah, we want them to get the best position possible.
If the client asked for it, you'd simply put it on a pole, right?
Yes, we could. Yeah, and for our cross-board teams, we do that. They're all on 2-meter range poles with bipods. Is how we do it on the cross-board team. The league survey team, because they have to walk so much, that becomes pretty difficult, especially, as you're walking up and down people's driveways, you've got, bushes and vehicles and, bikes from the kids and all kinds of stuff, because you're really walking up to, the side of every house or business, in the area.
Okay, now the utilities you're working for, I don't know if they ask you to go out and, as-built the stuff as they put it in, or are they doing that you know of?
Yeah, so that's definitely an option. We have offered that to utilities. We have definitely had some utilities who have asked us to go out and map that. So we do provide some mapping services, not as much as I would like. I heard you mention at the tail end of the last presentation about how it's you're personally wounded if someone doesn't take a measurement in an open trench. I feel the same way. I don't want to make. We spend so much time trying to find buried assets. If you just take the position when you have the opportunity, that's so much better. So we definitely do that sometimes when asked.
Definitely. Well, that's an area definitely for growth.
Yeah.
Yeah, I talked to some utilities where, they're trying to figure out how to capture things during construction. Do they have a dedicated crew that goes out? Do they have the inspectors do it? Or if they have a service outfit like yourself that's out and about in town at all times, that could be on a short on-call, so there's lots of room for opportunity there. So your GNSS units, those are multi-constellation, are they?
Yep.
Okay, so there was probably in choosing, we don't want to get into the brand or anything, you picked a threshold of capability and price, I would imagine.
Yeah, so our solution is hardware agnostic. We could use anything. We have some utilities that don't want to. They don't feel like they need sub-foot type accuracy. That's our preference, and that's always what we when we bid a job or we plan a job. We go in with that mindset. But occasionally they say, hey, look, we just don't want to do that. We know several that are using tablet level kind of accuracy. And if that's really what they want to do, we can do that. But in general, we want that better accuracy.
Well, as Eric said earlier today, that the biggest expense is labor on doing this sort of thing, and trying to go cheap on the hardware. It sort of wounds my heart that if somebody's going to bother to be out there, get the most precise you can for all the downstream uses. So I think we agree about that.
Part of my role is when I look at requests for proposals or quotes from different clients, and I'll do a full financial model of the whole project. And when you amortize the cost of the hardware over a 3-year project, it really becomes inconsequential. And so, to try to save a nickel, you're not even saving, it's less than a nickel you're really saving. Like I said, labor is by far, I mean, gas to drive around dwarfs the cost of better equipment.
Oh, yeah. All right, so we're about wrapped up for the day. Thanks again, Mark, at short notice coming on to do this presentation. I wanted a good end use presentation in this
My pleasure.
event. And that's going to wrap us up for the day.